Hey guys, we're going to look at inverse trig functions, and really this is just the pre-cal part of this. We're not going to do any derivatives quite yet, but first I'm just going to remind you about the inverse trig function themselves. So we have 6 trig functions. We have the sine, cosine, tangent, and then we have cosecant, secant, and cotangent. All of them have inverses, but when we take their inverses, they are not functions anymore. If you think about the sine graph, it is periodic. It's going to go up and down and up and down and up and down. It passes the vertical line test, but it fails the horizontal line test. So it's not a one-to-one, meaning it doesn't have an inverse function. Well, we can get around that if we restrict our domain. It allows us to have an actual inverse function for each of these 6. So I have drawn a picture of the inverse where I've already switched the x's and y's for each of these, and I've shown you the restricted domains. So if you want to, you can go ahead and pause and copy these down. What these are going to do is allow us to have a function for this inverse, and then our x values are going to fall in these new domains that we've restricted. So an example with inverse trig functions, just finding values, we have the arcsine of -1/2. We want to know where sine is equal to -1/2 is really what this is saying. But let me show you how we can do a little bit of work to pretty this and be exactly what I just told you. So arcsine of -1/2 is what I've got. Now I've written it as an equation. Now we're going to assume that it's the restricted domain. Well, I'm going to take the sine of both sides. So we have sine of y equals sine of arcsine of 1/2. Well, because sine and arcsine are inverses, they're opposites, this is really just going to free up that -1/2. So it's exactly what I told you it was going to be. Where is sine equal to -1/2? Well, we can think through our unit circle, but we want to make sure that our answer falls in the restricted domain of -1 to 1. The only one that does that is -pi/6. And I'll let you think through why that's true. If you have questions, we can look at it in class. So now the same goes for these next 2. We would build it the same way and then use the inverse operation. So go ahead and try number 2 and 3, and then I'll confirm it in just a sec. Okay, so for number 2, you should have gotten pi/2. And then number 3, you should have gotten pi/3. If we need to look at them in class, we absolutely can. On number 4, they've already got it built as an equation for us, so I'm going to do kind of what we just did, where I'm going to take the opposite of arctangent. Well, that's tangent. So I'm going to take the tangent of arctangent of 2x minus 3 equal to, I'm going to do it to the other side, tangent of pi/4. Arctangent, tangent, that just frees up that 2x minus 3. Those are opposites. And then tangent at pi/4, that's our root 2, so it just equals 1. Now we have a simple algebraic equation to solve. So add 3, so 2x equals 4, divide, and x equals 2. Now if I look at the restricted domain for tangent, it's -∞ to +∞. We don't have to restrict it. So 2 is perfectly fine. Use a calculator to evaluate this. Our calculator button that you're going to want to use is that one with the cosecant -1, like this, right here. And then 2.590. You can use your calculator right there. I'll let you go ahead and do that. If you were in radians, then you would have gotten 0.396. Okay, so looking at number 4, we've got cosine of arcsine of x. So these are definitely not opposites, so the x is not going to be just freed up. Okay, so first off, I'm going to write this as y equals arcsine of x. And now we're going to use right triangles to help us get through this. So we're going to draw a right triangle. We know that arc sine of x is the same thing as saying sine of y is equal to x. We just did that process just a little bit ago. So y is my angle right here. Here's my right angle. And I know that sine is opposite over hypotenuse. So this is x over 1. So opposite would be here, hypotenuse would be here. And then I can use the Pythagorean theorem to find my third side right here. So if I do something squared plus x squared equals 1, we can call this whatever you want. It doesn't matter. Let's go with a. A squared plus b squared equals c squared. So a squared plus x squared equals 1 squared, which is just 1. I want to know what the value of a is. So I'm going to subtract the x squared, so a squared equals 1 minus x squared, and a is equal to the square root of 1 minus x squared. So this side length right there is a. And I didn't show you that. Sorry. So 1 minus x squared, and then take the square root of it all. That's my value for a. Now, how does this help us? Well, I want the cosine of y. I can rewrite this as, instead of arc sine in this right here, I already called it y. So cosine of y is really what I'm trying to find there, because I've defined it as y right here. Well, cosine is simply just the adjacent over the hypotenuse. And I just found the adjacent, and the hypotenuse is 1. So my cosine of arc sine is the same thing as cosine of y, which is simply just what we found, 1 minus x squared. Take the square root, and this is my cosine, arc sine of x. Now, tangent is my next one, of arc secant of root 5 over 2. I'm going to take this arc secant that doesn't match the tangent, and I'm going to do the same thing. Y equals arc secant of root 5 over 2. This is the same thing as saying, well, what secant of y would equal root 5 over 2? Draw a triangle. Y is my angle. Here's my right angle. Secant is the reciprocal of cosine. So this is like hypotenuse over adjacent. It's the reciprocal of your cosine. So my hypotenuse is square root 5. My adjacent is 2. So I want to find this value. So I'll use a again. So we can go a squared plus b squared, which is 2. So 2 squared equals square root of 5 squared. Well, that's really a squared plus 4 equals 5. So a squared is equal to 1. Square root of 1 is simply just 1. So my a value from right there is equal to 1. And again, I didn't show you, I'm sorry. So let's think about how we can rewrite the tangent. So instead of saying tangent of arc secant of this right here, we can just say tangent of y. Well, tangent is equal to opposite, which is the a value, 1, over adjacent, which is 2. So my tangent of arc secant root 5 over 2 is simply just half. Right there. Okay, in this video I'm also going to go over inverse trig differentiation. So go ahead and pause and write down all of these formulas right here. They're going to be our inverse trig derivatives. I'm also going to show you the proof of arc sine, arc tangent, and arc secant. I'm not going to work through them, but I am going to show them to you. Go ahead and read through them. You can copy it down if you'd like. What I would like you to do, just see if it logically makes sense with the trig and with the calculus that we know already. Feel free to copy it if you'd like. I'll post the answer key so you'll have it But just read through. If there's anything that's confusing on them, we can definitely talk about them in class, but I'm not going to work through them just for time's sake. Now really, what we want to focus on is making sure that we know these derivatives up above, because I do not want to have to work through a proof every single time that I need to find the inverse or the derivative of an inverse trig function. Now, that being said, you absolutely can rework through these, but it might be worth your time to memorize these derivatives right here. And they're simply just formulas that we follow, and they are kind of complicated ones to memorize, so I'd recommend you start doing that ASAP. We're going to look at a couple of examples. Number one is the derivative of arc sine of 2x. So the first thing that we want to do is we want to make sure that we know what our formula is that we are working towards. And our formula for arc sine, you have it up above, I'll just write it here so we can go through it, is du over square root of 1 minus u squared. Well, that means that we probably should identify what our u is. The u is the thing inside right here, so this is our u. So what's the derivative of 2x? Well, our du is simply just 2. So 2 over the square root of 1 minus u, which is 2x squared. I can leave it like that, or I can simplify as square root of 1 minus 4x squared on the bottom like that. And that's simply just following the formula. It's really simple to do. The trickiest part is memorizing these formulas. So arctangent's formula is du over u squared plus 1. Well, our u is the thing inside right here. So our u is 3x, which means the derivative of that is simply just 3. So 3 over u squared, well, that's 3x, and we're going to square it, and then plus 1. So 3x squared, we can rewrite that as 9, so 3 over 9x squared plus 1. Pretty simple to follow if we know those formulas. Okay, let's do a couple more. Again, it's not really about a difficulty here. We just need to know which formula are we about to use. Cosine is the one we're, well, no. So we're going to take the derivative of arc cosine square root of x. Well, arc cosine, its formula is negative du over the square root of 1 minus u squared. This one looks a lot like the sine one, it's just the negative version. So cosine and sine are very much related. Here is my u. U is square root of x, which means my du, if you want to rewrite this with a power of half to help you, you can. We've got half x to the power of negative half. We can make that look a little bit prettier if you want to by saying that that is underneath. So 1 over 2x to the power of half. You can rewrite it like that. So now I'm just going to fill in my derivative. Negative du, that's negative 1 over 2x to the power of half, divided by the square root of 1 minus u squared. Well, that's square root of x, and then we're going to square it. So we definitely have some simplifying that can happen because we have a fraction inside of a fraction, and then we have a square and a square root going on right there. So if we multiply by the reciprocal, really what we have is we have negative 1 over 2x to the power of half times the reciprocal of this, well, that's just 1 over square root of 1 minus, and let's go ahead and make that square root of x squared just to be an x. And then it's just a matter of multiplying your fractions together, which is negative 1 over 2x to the power of half and then square root of 1 minus x. All of that's on the bottom. For number 4, we have the derivative of arcsecant of e to the power of 2x. Arcsecant has its own formula as well. Arcsecant is du over absolute value of u times the square root of u squared minus 1. So this is the formula we're working with. My u is e to the power of 2x. We know that the derivative of e to the power of 2x is pretty simple to do. We're going to go e to the power of 2x times the derivative of that power, which is just 2. So the derivative is 2e to the power of 2x. So that's by du. So let's go ahead and start putting things where they belong. So e to 2x, there we go. And then u, well, that was this one right here, so we have the absolute value of e to the power of 2x, and then square root of u squared, so e to the power of 2x, and then we're squaring it, minus 1. Now, a couple of things right here. We know that e to the power of x is always positive, so we don't really need this absolute value. So I can say 2e to the 2x over e to the 2x, and then 2x to the power of 2, that's really going to be e to the power of 4x inside of there, and then minus 1. One more thing that I notice is I have e to the power of 2x over e to the power of 2x, so those are really going to simplify to be 1. So I can say that this is 2 over the square root of e to the power of 4x minus 1. And that's about as far as we're going to get on simplifying there. And let's save this last point of inflection 1 for class.